Anyway, that's the distinction between alpha type 1 error and the p-value type 1 error. One is preset in advance, it's determined, and this has been calculated from the statistical data. All right, so I got to tell you the p-value is crucial for everything you do from here on out in this course. Okay, if you, for example, read a medical journal or a psychology journal, any kind of academic journal or publication in which statistics has been done, then you're going to find p-values all over the place. And so that's our standard that we use for determining if something is significant or not. Alright, well, let's look at some a little bit more terminology in the book. And they define the p-value here on page 271. It says the p-value is a probability of getting the observed data or more extreme data when the null hypothesis is true. Okay, so that's saying in different words what I've told you. Probability of getting the observed data or more extreme. The observed data was 7.0, not 5.1. When the null hypothesis is true. That's the p-value. And in this case, it turned out to be very small. So, what else can we get into here? Page 272 says, near the bottom left-hand corner, when a null hypothesis is rejected, the sample result is statistically significant. Alright, so I want to talk about that notion of statistical significance. And there are two kinds of significance as I see it. There is statistical significance and there is a subjective significance. My terminology as far as the subjective. What are we talking about here? Alright, now I want you to think about this scenario. Suppose that in the United States, people live on average to be 78 years old, 78.0 years old. I'm just throwing that number out. I know it's kind of close to what it actually is. I'm not sure what the exact number is, but play along with me. So, national average, 78.0. Someone goes through, does a lot of research into Ohio, and finds out Ohioans live to be 78.1. Is that a significant difference? Well, it depends on what you call significant, okay? It is very likely, if you had a very large sample of Ohioans, thousands, that when you calculate a hypothesis test, calculate the p-value, comparing Ohio with the national average, sort of like we did up here with the workdays lost due to illness. If your sample is extremely large, you will probably have a very small p-value. In other words, we would reject the null hypothesis and say, yes, there is a significant difference between these two numbers. So, as it turns out, large samples normally end up in decisive, significant results. Particularly very, very large samples. So if I had a million people in my sample, I can about guarantee that we're going to find a significant difference. That's statistical significance. Okay, in other words, statistical significance works off the laws of probability. It uses probability to determine what is statistically significant or not. That's the basis on which we reject the null hypothesis or fail to reject the null hypothesis. Subjective significance. Yeah, now, you would look at it and say, well, so what? Who cares? 1/10 of a year? Does it matter? Well, unless you're on the verge of death, a tenth of a year could matter a lot, but most people think, well, doesn't matter much. Very, very tiny. So a difference in two numbers can be statistically significant, but not subjectively significant. In other words, we'd say, well, we don't care. They're so close together, it doesn't matter. They're close enough. That's subjective. That's bringing opinion into it. And so statistical significance is really a different form of significance. And we need to kind of keep that in mind. All right, well, let's do some more problems.